Hello, my fifth grade scientists. So I hear that you are learning about the four Earth spheres right now. There's the geosphere, which is made up of land and rocks. There's the atmosphere, which is made up of the air and gases that surround our planet. There's the biosphere, which is all living things on our planet. And then there is the hydrosphere, which is the water on our planet. So for today, you might be able to guess, just based on what we're seeing all around us, we are going to focus on learning about the hydrosphere. So we're going to be talking about all different forms of water, different bodies of water, and kind of just get to know the hydrosphere really, really well. So as we are learning today, I'm going to be mentioning lots of different types of water. I'll mention different bodies of water. I'll mention different forms of water. So I have a challenge for you. As we are exploring the hydrosphere today, I want you, if you hear something that you think makes up part of the hydrosphere, whether it's a body of water or a form of water, write it down. My challenge for you is to try and come up with 10 different things that are part of the hydrosphere. All right, so as you're listening, you might want to jot those down. All right, so let's get started and learn a little bit about the hydrosphere. There are many kinds and forms of water all over the planet. Water appears in liquid form as rain and forming lakes, oceans, rivers, and seas. Water appears as a gas in the form of water vapor and exists as a solid in the form of ice and snow. Oceans and seas contain most of the world's water. Since this water contains salt, it's unsuitable for human consumption and for agriculture. Human consumption means drinking, so we can't drink it. Although oceans and therefore water cover 71% of the Earth's surface, humans have only explored as little as 5% of the Earth's oceans. Fresh water, the water humans need for agriculture and to drink, can be found in large bodies of water called lakes. Lakes and other freshwater bodies cover about 20% of the Earth's surface. Rivers are freshwater channels running over land. Rivers flow towards an ocean, sea, lake, or another river. Water from rivers is used by humans for both consumption and agricultural use. Water can also be found in clouds as condensed water vapor. Water falling from clouds is called precipitation. Types of precipitation include snow, rain, or a combination of both called sleet. "97% of Earth's water is found in oceans and seas. The remaining 3% is fresh water. However, most of it is locked up in the polar ice caps, glaciers, and permafrost. Permafrost is when there is water in the soil in places where it's very, very cold, so it stays permanently frozen. Of all the world's water, now this is an insane number. Of all the world's water, humans can only access 0.007% for drinking and for farming. So this represents a whole big glass of water. This represents all the water on the earth. And if you look over here, 97.5% is salt water, and that little bit at the top, 2.5% is fresh water. But like we said, most of that is frozen, so we can't even access it. So less than 0.1% of the Earth's water can we use to drink and to farm and for anything else we need fresh water for. So my question for you is, why do you think it's important for us to protect and preserve that drinkable fresh water? Why do you think it's important for us to conserve water or save water and keep it clean and keep it drinkable for us? Think about that. All right, we are going to move to our next scene. What? Underwear? Wait a minute. What does this have to do with the hydrosphere? We got socks. We got pants. We got dresses. What's happening? What might this have to do with the hydrosphere? Clothes hanging out to dry. So the reason, it's not just silly, the reason we've got clothes hanging out to dry here is we're going to talk a little bit about the water cycle. Water vapor is continually cycling around Earth via processes called evaporation and precipitation. These processes are part of a larger system called a water cycle. The process of evaporation is involved in the creation of clouds, and the term precipitation refers to water that falls from the clouds. Heat from the sun excites the tightly clustered water molecules, which start to drift apart. When this occurs, the water becomes a gas called water vapor, which rises into the sky, leaving the clothes dry. This process is called evaporation. When the water vapor rises, it starts to cool down, which encourages the water molecules to get closer together. As more water vapor arrives via wind and evaporation, a cloud starts to form. Once a cloud is formed, if the water vapor continues to condense or get closer together, water droplets begin to form. Once these water droplets are too heavy to remain in the air, they fall as rain or hail. This is supposed to be snow. I don't think it really looks like snow. It looks like bubbles to me, but we're going to talk about snow here. Snow is formed when the water vapor becomes frozen and turns into tiny ice crystals. As these ice crystals condense, they join up with other ice crystals before becoming too heavy to remain in the air. All right, so we talked all about the water cycle, all the different stages of the water cycle. There's two really, really big words we need to know when it comes to the water cycle, and that's evaporation and precipitation. So take a minute now and kind of describe in your own words the process of the water cycle. What exactly happens during the process of the water cycle? Describe it the way you would describe it, just in your own words. All right. we're going to move to our next scene. This is probably my favorite scene, the next one, so get ready. All right, so you might have guessed, we're going to talk about some of the life that lives in water. We're going to talk about the oceans. Oceans and seas are huge bodies of salt water that cover 71% of the Earth's surface. A sea is a body of salt water that is bordered by land, while oceans are wide expanses of salt water. Seas and oceans vary in depth. The depth of the water decides how much sunlight can travel through, which in turn determines the species of plants and animals that live there. The zone where the sea meets the land is called the coast. Coasts around the world measure about 193,000 miles. Coastal areas can also be called shores or seasides. The sea gets deeper as it follows the continental shelf. The continental shelf is the area of land found below sea level that is part of the larger landmass. This part of the sea can contain coral reefs in warmer climates. Between the continental shelf and the ocean floor lies an area called the continental slope. Animals such as deep-sea fish, crabs, and whales can be found living in these areas. No sunlight reaches the ocean floor, and animals living here need to have evolved special adaptations, with some species even producing their own light. There's a very impressive fancy word for animals that produce their own light, or living things that produce their own light. We call it bio, which stands for life, and luminescence, which is light. Bioluminescence. The deepest known point of the ocean is the Mariana Trench, measured at 36,070 feet. So way down there at the ocean floor, lots of animals have had to adapt to live down there with no light. We've got our very scary looking guy here with his light bulb. You might have heard of this type of fish before. Probably not quite this big, and he wouldn't be up this close to the surface, but this is kind of a magical version of an anglerfish. So let's talk a little bit about this scene. We had a lot of different animals, a lot of different things. We talked about the continental shelf. We talked about the shores. We talked about whales and animals that live in the ocean. Now, remember our challenge that we had earlier, which was to write down 10 different things that make up the hydrosphere. So my question for you is, are these things, this anglerfish, the flying fish we have over here, the jellyfish, the dolphins, do they make up part of the hydrosphere? We're talking about them during our VR exploration of the hydrosphere. Are they part of the hydrosphere, or are they part of one of our other 4 spheres? And then what about the continental shelf, which was part of that landmass down under the ocean? Would that be part of the hydrosphere, or would that be part of one of the other spheres? So write down What sphere do you think a whale would belong to? Remember, I'll remind you of the 4 spheres. We have the biosphere, we have the geosphere, we have the atmosphere, and the hydrosphere. So which of those 4 spheres would our whales belong to? And which of those 4 spheres would the continental shelf, which is part of that larger land mass below the ocean, what would that belong to? Something to think about so we can tell the difference between those 4 Earth systems. All right, let's keep moving. Lakes are large areas of fresh water surrounded by land. Many lakes in the northern hemisphere were formed by glacial activities, whereas lakes found in the southern hemisphere are more commonly created by land depression. So what they mean here, when we say in the northern hemisphere lakes were formed by glacial activities, if you're not sure what a glacier is, that's a big kind of frozen, almost mountain of ice. And long ago, there were lots and lots of glaciers around the northern hemisphere. And they would kind of slide along the earth, and they would form these kind of depressions in the earth as they slid along. And that would lead to these lakes being formed. Lakes are standalone bodies of water, not directly connected to the sea. Otherwise, they would be called lagoons. I didn't know that before this. In most cases, lakes are fed and drained by rivers and streams. Some lakes were formed by water falling into low-lying areas and pooling. Other lakes were created after big, moving mountains of ice called glaciers pushed along land and changed the earth, making deep bowls where lakes formed when the glaciers melted. Lake Baikal in Russia, the deepest lake in the world, is 5,354 feet deep at its deepest point. It's known as the largest lake in the world because it holds the most water. This ancient lake is estimated to be 25 to 30 million years old. A river is a body of water that flows. Rather than sitting mostly in one place, like lakes and ponds, rivers move in one direction. Most rivers begin in higher areas, such as a mountain, and end up flowing into the sea. The place where the river begins is called its source. The source may be a melting glacier, a spring, or a lake. Rain, snowfall, and groundwater also help a river to form. As the river travels over flatter areas, it curves like an S. These curves are called meanders. I love that word, meanders. As the river travels, it cuts through the earth, making new shapes and pushing deep into the rock. Some rivers also fall over rocks and cliffs, making waterfalls. All rivers empty into larger bodies of water. Many rivers reach the ocean while others flow into seas or large lakes. The area where the river ends is called the river's mouth. Thirty 30% of the Earth's fresh water is located underground. Groundwater is stored in the spaces between soil and rock. When groundwater is collected in one area, it's called an aquifer. In some areas, the groundwater appears on the Earth's surface. Groundwater is stored in the spaces between soil and rock in something called aquifers. Aquifers are like reservoirs, only they're located underground. Wells are built to reach an aquifer. So if someone made a well, they would dig down, down, down through the earth until they got to the water down in that aquifer, down below the earth. In some areas, the groundwater appears on the Earth's surface. This is called a spring. Hot springs occur when the groundwater has been in contact with molten rock from under the Earth. The Grand Prismatic Spring in the United States is a type of hot spring. It is famous for its multi-hued appearance, which is caused by the bacteria living within it. A different type of cyanobacteria produces each colored band. I've never been there, but I would love to see it. This looks really, really amazing to me. All right. So we're going to go to our final scene now. It's kind of a bummer. It's kind of ending on a not so happy note on our tour of the hydrosphere today. We're going to talk about humans and our impact on the hydrosphere. All animals and plants need the hydrosphere to stay alive. In order for humans to survive, we need to look after the 0.007% of fresh water available to us. Stricter environmental regulations for industry and agriculture can ensure freshwater supplies remain suitable for human and other species to use. Before stricter environmental laws, factories got rid of much of their waste into river systems. This type of water pollution can quickly cause a river to become unusable for humans. Modern-day agricultural practices or farming practices can affect life in rivers, lakes, and oceans. When farmers put chemicals on their fields to get rid of weeds and insects, the rainwater washes the chemicals into the rivers. Contaminated water can also seep into the groundwater. When oil spills occur, oil floats on top of the water, forming a barrier that prevents sunlight and oxygen from getting through. Phytoplankton die, which are the basis or the start of many food chains. Animals might suffocate, and animals coated by oil can't regulate their body temperature to keep warm. So even though this is kind of a sad note to end on, let's try and end on somewhat of a positive note. Let's talk a little bit about, or why don't you think about and write down, what is something that we can do to protect the Earth's water and keep the hydrosphere safe? So think about the different ways we talked about that humans have impacted the hydrosphere in not so great ways. And think about, what do you think we could do to protect water and protect the hydrosphere? All right, I hope you enjoyed our little tour today. It's pretty interesting kind of take on VR. It's almost like we're living in a storybook. All right, so have a wonderful day, and I will see you all soon. Bye.